Earth started as a disk of dust and gas, spinning incredibly rapidly around a star. The star that we now call our sun. Bits of this dust were colliding off each other, aggregating into larger and larger lumps. And eventually one of these lumps became big enough that it attained its own gravitational force. The combination of gravity and speed raised the temperature to the extent that it melted this aggregation of rock and material into a flaming ball that was spinning through space. This kind of prototypical Earth. So this Earth was still colliding, sometimes with really significant other space objects. And one of the more recent collisions jettisoned a huge amount of material into the Earth's atmosphere, actually into the Earth's orbit, and that eventually aggregated into what we now call our moon. And then slowly the surface of the Earth coalesced and cooled into the crust that we have now, solid rock floating on this ocean of magma, molten rock just under the surface. Some of this material on the top was denser and it formed lower depressions. So now we're getting somewhere, aren't we? Now we have a universe, we have a galaxy, the Milky Way, we have Earth, our planet, floating through space, and the surface of the planet, the crust, is now hardening. And we need some water. Life relies on water. So this is pretty amazing where the water comes from. There's a lot of people who think the water we have on the Earth now wasn't there at the beginning, that a lot of it actually arrived on asteroids from space. There were lots of collisions with this early Earth. A lot of the water arrived, impacted the Earth, evaporated, condensed, and flowed slowly into these lower areas of the crust. So now we have the oceans. We have an Earth, we have oceans, we have water, which is cooling to a sufficiently low temperature that it can support life. So that's pretty cool. Now we have something. In the beginning, God made the heavens and the earth. We've got that far. But it's still a long time ago. And still, there was a very large gap before the first humans arrived. So we're going to move forward through time, a lot of billions of years, to a measly 66 million years ago. Now why that? That seems a bit arbitrary. Well, it turns out the fossil record shows us that about this time, 66 million years ago, almost all of the larger dinosaurs suddenly disappeared. They suddenly went extinct. Now why was that? Well, I think the answer, the current theory is, the answer lies in this element called iridium. It's a metal. It's actually really rare in the surface of the Earth, much rarer in the crust than gold is. But iridium's actually really common in certain space objects, meteorites that come from space. And geologists, scientists who study rock, have discovered a thin layer of iridium in more than 100 places around the planet, all over the planet basically, corresponding in the geological record to this period about 66 million years ago. So how does that connect to the dinosaurs? Well, the idea is that an enormous meteorite struck the Earth at about this time. We now have a pretty good idea of where it is, or where it landed. Down in the Yucatan Peninsula in Mexico, there's a crater. It's about 180 kilometers across and up to 14 kilometers deep. So you can imagine the size of the thing that must have struck the Earth to cause that. Now that encounter, that blast, jettisoned a huge amount of material into space, including lots of bits of fragmented meteorite, which circulated around the atmosphere, settled out on the surface of the Earth, and created this thin layer of meteorite debris containing iridium all the way around the Earth. So what? Well, first of all, this impact obviously generated an incredible amount of heat, this sort of nuclear blast. So most of the dinosaurs were just roasted immediately. They didn't have anywhere to go. They're large and slow. They just got killed straight away. But from an ecological perspective, a stewardship perspective, what's much more interesting is what happened next. So this impact, think about this crater 14 kilometers deep, the amount of material that was jettisoned into the atmosphere settled around the whole of the Earth and blotted out the sun. So suddenly, quite suddenly, the amount of sunlight striking the surface of the Earth, obviously that's warmth, that's temperature, was substantially reduced. It got darker, it got colder, and with that probably it started to rain more. The rain was colder, more unpredictable. So within a very short period of time, the whole global climate went from something rather stable and tropical and beneficent for these lovely dinosaurs into something much more unstable, much colder and gnarlier, and they just couldn't cope.